Good evening, ladies and gentlemen, dear guests. Let me welcome you all on behalf of the delegation of Prague to the European Union at the Prague House tonight at this joint event, another edition of the Science Café. And it is our pleasure to organize it together with the representation of South Moravian region to the European Union and the Czech Liaison Office for Education and Research. And thank you all for coming in this lovely spring evening. We hope we will have an interesting event ahead. And this edition of the Science Café will focus on young, talented Czech scientists who are already successful even in the international context, despite the fact that they are just at the beginning of their careers. So tonight we will discuss their personal stories, their research achievements, and also the way how they promote the science to the broader public. The event will be moderated by Tomáš Polák from the European Parliament, and we will present tonight two great young, talented scientists from the Czech Republic, Anna Krebsová and Tomáš Čermák. I will not further introduce them because they will be presented by my colleague and by the moderator. So let me just wish you a great evening at the Prague House. Feel free to join actively in the discussion that will follow, and also we have had the informal part after the main part of the evening, so you can later join for less informal talks with over the glass of wine and some refreshments. But we are just starting, and I now give the floor to Lenka.
Thank you, Lucia. So, dear ladies, gentlemen, friends of Science Café, and also our colleagues, as was already mentioned, I'm Lenka. I'm head of Czech Liaison Office for Education and Research here in Brussels, and also it's also my pleasure as well to welcome you for the first edition of the Science Café of this year. As was already mentioned, the theme of today's Science Café is a new generation of Czech scientists. And it's really great for us actually to present you Anna and Tomáš, because we are more than happy that actually they accepted our invitation to come and to be part of the Science Café. So we hope that they will let you know, or they will discuss how it is to start actually a scientific career in a European and international context. And also they will share their personal insights into motivation, actually why they decided to start, research career, what were their early scientific achievements, and what it is actually to work in international work team. And what is also quite important is to discuss what are challenges of starting a research career. As was already mentioned, what is not the least, and the least important, is actually also how to communicate to the public what is about science and how to discuss all their achievements and also the outputs. However, we hope that the discussion is going to be not only about present days, but also about the future. So what are their thoughts about the views on the future of science in Europe, what they think about the cross-disciplinarity and international collaboration, and also what are their own ambition for the future. As was already said, we are also more than happy that we are cooperating with two, I would say, already traditional partners for the event. So I would like to thank the representation of South Moravia to the region, and also to the Prague House, in whose beautiful premises we today are. And my last task today is to present you a moderator of this event, and it's Tomáš Polák. He's behind me, just behind me. So, Tomáš, he's a communication professional with over 11 years of experience in media, journalism and public relations. He studied media studies and business management in Prague and gained international experience abroad as well. He began his career in commercial media and worked as a journalist and TV reporter. He currently works as a public relations advisor at the European Parliament, where he is responsible for PR and media relations for the Czech delegation in the Greens EFA group. Alongside his institutional work, he focuses on communication, training and education. So, Tomáš, the floor is yours, and thank you.
Thank you, Lenka. And thank you, all of you. Good evening, ladies. Also from me, welcome to Prague House and welcome to a special edition of Science Café. Special not only because it's moderated by me, but also because we have two wonderful guests here. They are both young, they are both Czech, they are both extremely interesting and already internationally recognized. One of them is working on saving space from trash, and the other one is actually working on saving water here on Earth. My name is Tomáš Polák, as you already heard, and we have here Anna Krebsová. Please welcome her. And Tomáš Čermák, also. Anna, let me start briefly with explaining a little bit more about you first. You're part of LASAR team, which originally is acronym for Laser Satellite Recovery. And with this team, you won 2 out of 3 awards in Conrad Challenge. For those who don't know, it's a very prestigious international competition, innovation competition, which takes place in Houston. And it had about 2,000 participants. Please tell me, how did it feel? You were 18 years old, if I'm not mistaken, when you won this competition. How did it feel for you when you heard such a positive feedback from NASA experts?
Good evening, everyone. It was something imaginable. We were a 5-member team. This team, 5 students, 5 high school students from the Czech Republic, with our team mentor on the left side, Honza Spratek, popularizer of the space from Prague Planetarium. And we are from different cities from the Czech Republic. So I am from the totally west side, and the guys are from the east side, from Brno. So we worked online, and when we first met together as a 5 or 6-member team, was at the airport before we flew to Houston.
You never met before physically, it was only online.
Yeah, all of us. But I think week or 2 weeks before the flight to the final in Houston, we met in Brno to practice our presentation. So I think that we impressed the judges for our teamwork, for our best presentation that we ever made together, because we
You showed them the best presentation they ever seen, I guess. You will show us as well in a few moments. We actually have a little satellite here. I can already spoiler that. But before we get back to you, let's go to Tomáš. I will introduce you and your project also a little bit more. You also won a global competition with your project. In your case, it was an environmental competition called the Earth Prize, which evaluated also thousands of projects from more than 150 countries worldwide. And you and your Slovak friend or colleague, Anna Podmanická, presented a project called PURA. It's about purification water. And you were actually the first European that ever won this competition. So tell me, actually, one more thing I have to tell about you, because most recently you were also one of the under 30 Forbes list. So those are like 2 different successes, but which made you feel more happy?
So good evening from me as well. So I see that we are already starting on a controversial note. Since I was little, I'm very bad at deciding. So I think both of them in different ways, because as you said, the Earth Prize is for me a huge scientific achievement. It was for years of research, for innovation, for technology that is actually new, that can help the environment significantly. And Forbes was a completely different story, but in a way even more fulfilling, because it showed that you can bring science to the mainstream media and like in front of business people, politicians, musicians, artists, and that people are actually extremely interested in science, and that it's actually something that our society values a lot.
So you're more proud on Forbes then, I guess I hear.
I will not decide now. I was bad at deciding when I was a little kid. I'm still bad at deciding.
If I go back to the Earth Prize, how old were you when you won this?
I was 18.
18.
Yes.
Wow. Also, for those who don't know you yet, you might recognize Tomáš from actually Ursula von der Leyen's speech, which is very viewed here in Brussels, State of the Union speech, because she specifically mentioned you and your project. How did you react when you heard that she mentioned you?
We were number one. We were extremely surprised. Point one. Point two. It made me so proud because European innovation is amazing. We are actually great in innovation. We just don't like to admit it sometimes. And we don't believe in ourselves enough. And for me, as a Czech person, it was two things. One, Europe, and that was the Earth Prize. Like, we brought the Earth Prize for the first time to Europe. That the European innovation is world level. We are not just some kind of museum. And for me as a Czech person, it was like, yes, Czech flag can fly high above Europe and above the world. So it was like, I was extremely proud.
Well, we are also very proud. Also, as a Czech Republic person, I am very proud. But when I hear your stories, you're basically both kind of solving a global problem. Do I read it well? Because you're saving trash from orbit, you're saving water here on Earth. Do you see it the same way, Anička?
Yeah, I think so, because we are solving the problems that other make. So I believe that our solutions, our both solutions, can make better world for all of us.
Yeah, exactly. I think that we are finding innovations, we are finding the treasure when others see trash, because actually it's not like we are, of course, with climate change, it's often said that we are destroying our planet. Yes, that's true. But on the other hand, like every innovation that human brought, for example, the invention of antibiotics, necessarily causes some downsides. For example, the pollution in the water that is affecting us, it's creating antibiotic-resistant strains of bacteria, right? So that could cause millions of deaths in the future. But antibiotics saved millions of lives. It doesn't mean that we will stop using them. We just need to innovate even more and discover how to solve this downside of our innovation.
Thank you, Tomáš. Let's go back to you, Anička, and to your project more specifically. Why is it actually such a big problem, non-functioning satellites in orbit and space? Why do we have to solve that? Space is quite big, right?
Yeah, really big. In my opinion, the space exploration is really useful for our future on the Earth. So it's nice, and we used to send something and someone into space for the answers of our questions. But when we something sent into our Earth's orbit, then it can met something else and make it space debris, because
which is like a space trash, basically.
Yeah. Because space debris fly in a velocity of something like 28,000 kilometers per hour. That means 7.5 kilometers per second. And when the two objects met each other, then they won't only broke in half or something like that, but they will make more and more tens or thousands of small trashes from millimeter to centimeter size, centimeters size. So it make the orbit more danger for the functional objects and also for astronauts on the ISS, International Space Station, or
because it can literally hit them and kill them.
Yeah.
And can you guess, maybe you know it exactly, how much like percentage of objects which are sent by humans on our orbit are actually debris, trash, non-functioning?
I think that I'm not able to say some number, but
would you say it's a majority or still a little part?
Because we have the gravity. In the Earth's orbit is still gravity. Also at 400 or 500 kilometers above the Earth. So everything that is there goes slowly down to the Earth. And in months or years, all of the debris will slow down too much to the mesosphere when it burn down. So
eventually it's going to be fine.
Yeah, but we send more and more new satellites and other objects, and they make more and more debris.
Tomáš, when you hear Anička talking about space trash, space sustainability, we can say, do you feel or do you hear any similarities, parallels with your work and sustainability here on Earth?
I think that the main parallel is that we still have time in both those problems, because what Anička said is very true. Like there are theories that if so much satellites break, it will cause cascade, and we could potentially lose the space forever, basically, because like one satellite fractures to like thousands and thousands of different fragments. And with water, what we pump out of our water treatment facilities. So if you at home, when you turn on the sink, it just flows into the tubes, and you never interest yourself in what happens afterwards, right? But the reality is that, like, at the end, when the water gets cleaned, there are a lot of chemicals, and our current technology does basically nothing, essentially. You would be surprised. There are like 3,000 nanograms of caffeine per liter. There are 30, 50 nanograms of ketamine per liter. So THC, different types of cannabis chemicals, there is a lot of them. There is a lot of drugs, there is a lot of antibiotics. But we pump them out of the river because the water we drink is still mostly underground sources. So you can imagine you dig up the well and you just like pull the water out, right? But not all countries in the world are so lucky as we are. Some Asian countries now need to use that water directly, and that's a huge issue because the water we drink, it's still filtered through layers and layers of soil, and it's still, there is sunlight and everything that, all these things that attack the chemicals. So we don't drink zero. This water I have here is not like zero, 100% chemical free, but it's, let's say, decreased by 30%, by 70%. So it's a small fraction of it. But imagine if you drank the water that we consider clean, that we pump into the rivers, that is not actually clean. So we still have time, but with climate change, this becomes more and more of an issue that will cause a lot of problems if we don't address it.
Let's now go into something very difficult, I think, because it's going to be explaining very advanced science in very simple terms, please, for me. You actually, Anička, brought a little satellite here. So can you explain us what we see here? How does it work? We actually even see videos here, which you can explain. What is it about, actually?
Yeah, this is our own satellite called LASAR sat. This is a 3D printed model of the satellite. And actually, this is the size of the satellite that flies around our Earth.
So you sent your own satellites on orbit?
Yeah.
Wow.
And this cube have only 10 centimeters per the
per side.
Yeah, per side. And here we can see the video from the integration, which is the process of integration the satellite into this box. This is a deployer, and to this box we can take
you can bring it to the space with this. How do you do it?
On the rocket.
On the rocket, okay.
Yeah, because this box will go on the rocket to the United States, and when the rocket launched and goes into the orbit, then the satellite goes out from this box, and they fly around our Earth.
How long does it gonna fly there?
Actually, those small CubeSats, 5 years.
And what's on, because you also see some message on this satellite, what's written there?
Here?
Yes.
Yeah. It seems like
maybe some child wrote on it, no?
Yeah. But it's actually a sign of Stephen Bowen, which is an American astronaut, and he was only 2 or 3 weeks ago in the Czech Republic, in Prague, and we spoke with him about the Czech space associations. So we had the opportunity to talk with him, and he signed our 3D printed model.
What did you ask him?
Oh, that's the hard question.
Or what did he ask you, maybe?
It's so far ago.
Wasn't it 2 weeks ago, you said?
Yeah, but you surprised me.
Time flies.
Yeah, really fast, like a satellite.
Can I have a question? I need to ask.
Please.
What is this parabolic thing? The shiny metal thing? I need to know.
This was shining thing.
Like there is for you to see. This is what interests me. There is like a ball thing that I absolutely need to do.
It looks like a camera to me.
A camera is here, the black one, circle, but there is gold parabol in the nylon in the middle, because we send our satellite to the orbit for the satellite is the best target for us to test lasers through the atmosphere for our future plans with the orbiting the debris. But when we hit this parabola with a laser from the ground, then all of the energy will goes to the middle, and we can, through the laser, melting the nylon, and in the okolí
surroundings, yeah.
We can recognize how many energy we can through
like the power of the laser.
Yeah, we can send through the atmosphere, because the nylon is one of the materials that we used to build some satellites, and it's also the material of space debris. So we want to test the melting of the nylon for the mass of the future laser.
So let me just, if I got it right. So basically, this is the first step for you to test how much energy you need to prove your theory of putting laser up to the satellites or another space trash to make them kind of deorbit from how they are going, so they can go faster to the Earth, right?
Yeah.
And then they can just explode and they will be fine.
Actually, they will slow down, but they will go faster to the Earth. So it's something like action in reaction, because when we will hit the space debris with the laser, we will melting the material, and when the pieces of the material goes on one side, then the space debris slow down to the other side, and it makes the debris slow, and it goes down really faster than normal.
Oh, and specifically this satellite, well, not this one, because this one is here, but the one which is on the in the Earth or in the space. How fast? How much time does it take to go around the world?
One circle or ellipse around the world takes something about 94 minutes.
So it's very fast.
Really fast.
How come it's so fast?
It's because the start energy or start velocity from the rocket. Because when the rocket fly with the satellites on a board and put them out, they have one and only velocity. And then it goes...
almost forever, for 5 years, as you said.
Yeah. Because in the space is a vacuum, and the satellites haven't got any push or
Pressure or friction.
Air pressure to slow down. So they only use the energy and the
velocity, speed.
Yeah, and the speed for aby vyvážili
to balance
the gravity.
I see. Okay, now I will go to Tomáš, and please, can you find out where the satellite is right now? Because it really it's interesting to me. But Tomáš, let's go back to you. Your projects also sounds very, very complex. I read some words like cold plasma, photocatalysis. Yes, so how do you explain this project PURA to me? To someone who is not a scientist.
You need to know that before this talk, I was specifically advised that I can never use the word photocatalysis entirely. So
let's not use it anymore.
Yeah. So let's play a bingo. If I say it, I lose. So basically, what we did is, as I said, there are currently there is not a lot of methods that actually remove, and none of them is currently implemented. So we started looking what could be it, and I started with what you said, cold plasma, which is a very fancy word for a lightning. If you see a lightning, it's a type of discharge, because as you can see, air is normally non-conductive, but if we try hard enough and if we push a lot of electricity through it, it will become conductive. And it has very interesting properties, and I actually started my research in how we could reuse the face masks, because if you remember the dreadful times of COVID where we...
Yes, we do, unfortunately.
I know. So let's forget that again. But that's how I started my research, by destroying bacteria. But actually destroying bacteria and destroying water pollution is far more similar than you would expect. So we combined these two methods that both produce, like photocatalysis, is a powder that you just put into the water, and it's activated by the sun, by light, just by light. And both of these two very different methods. On one side, you have some powder that you put into water and you shine some light through it. And on the other side, you have literal lightning in your laboratory. They produce very similar results for the water. They produce those very aggressive particles. Like, imagine them like very angry particles that just are not very happy with their lives. And they just want to go about destroying anything they can find. And the thing they can find is the bacteria or the drug in the water.
And how effective is it? How much bacteria, how much drugs does it?
What we managed to do, that's the core of what we discovered, is that we managed to do like 90% of, let's say, sulfonamide antibiotics, a type of antibiotic that your doctor might prescribe to you, 90% of them in 3 minutes.
Wow, that sounds like a lot.
Yeah, that's the main advantage of what we basically made, is that it's very efficient, it's very effective, and it removes large amounts of these drugs and pharmaceuticals from the water.
And this is actually the project that won you the prize.
Yes, this is what convinced the panels and panels of juries. I don't even remember how. It was too much time.
And when is your project now? Like, why is it not used everywhere now and it's so effective?
Give us some time. The thing is that what we did was basic research, essentially. So now, because I always pushed for the fact that research is amazing, great, but writing research papers doesn't actually clean the water. I tried putting my paper into the water, it just doesn't work. So now we are trying to implement it into something real. So we are trying to make a spin-off. The research is out there, but we don't want Asia or the United States taking it and making it, because I think it would be nice if this was something that we were able to do in Europe, because we have been and we are the leader in environmental innovation, and I think that's why I'm attempting to bring this actually to reality.
But it is in reality, because you told me when we were preparing for this Science Café that you actually were able to purify some amount of water.
Yeah, it works. We have functional prototypes, but now the problem is, the technology absolutely works. But now we can purify few glasses like these. Right? It's very small. Everything, the buildings, the laboratories are small, so I could not bring like a big thing into it. But now we are working, because what we need is like thousands upon thousands of liters of water, and now is the scaling up that matters.
So maybe here actually also are some lawmakers, or definitely some assistants to lawmakers. So what would be your message to them? What's the problem? How can we help you?
For example, what we found out is that, especially now in the spin-off process, is that the water treatment plants are mostly municipal, or they are state co-owned. It's not very privatized sector throughout Europe, and there needs to be a strong push from the side of state, from the side of EU. There is currently legislation being implemented on that we should have water free of like antibiotics, of drugs. But currently the legislation is here, but we really don't know how it's gonna be done, right? So that's a huge issue, because like one thing is to say that the water has to be clean, the other thing is how are we gonna do it? So I have encountered a large support from the public, because when I try to kind of speak about this problem, it's an issue that is very rare, in that people across the spectrum can agree that this is an issue, right? That having drugs and antibiotics in the water is, like, by our intuition, not very good. And I think that we should use this rare advantage to push for this. When we have time, and if we start this innovation, it's also amazing for startups, business, and economics of Europe. Essentially, it's not only environmental, it's also like the entire world wants to solve this issue.
So if Mrs. President Ursula von der Leyen was here right now, what would you tell her?
Support. Well, that's a very high ask, I need to say, but
go.
The main thing is that we are great at innovation in Europe. We have many, and especially, as I said, environmental innovation. And environmental innovation isn't just something that...
I think she would be happy to hear that.
Yeah, but it's true. It's the truth. Like we sometimes say to ourselves that we are not, but we are. And especially the environmental innovation, which isn't something that is... people imagine that it's just for the sake of environment, right? It's just a Green Deal or something like... No. Environmental innovation also brings economic advantages because there are, for example, I will give you a specific example. In Europe, there are one of the few startups that make fertilizers not using the Haber-Bosch process, which is a process that produces 10% or something like that of global CO2.
You're losing me. So one message for Ursula.
Message for Ursula von der Leyen is support the European innovation, support the startups, make it less bureaucratic because we have the innovation here. We just need to develop it.
Less bureaucracy. We hear that a lot. Anička, do you agree with this? Or what would be your message to lawmakers? How to make your life easier as a scientist? You also told me that you agree with less bureaucracy, right? Is there something else you want to add? You can just say you agree. I have more questions.
Less administration and more time for science. That is.
Easy. Easy peasy. Thank you. You already got me where the satellite is right now?
Yeah, I have it here on the website. And during this short interview or short part between Tomáš and Tomáš, we were above Peru, Chile, Argentina, and now we are above Uruguay. So.
And everyone can see this on a website. Everyone can anytime just go there. Which website is that?
Satnox. db.satnox.org.
And I can find any satellites there or just yours?
Yeah.
Any satellite?
Any satellite.
Tonight, before you go to sleep, just watch the satellite.
Yeah.
Yeah, because that brings me to my another question, because you are actually now preparing another project, which is about bringing antennas to schools. So tell me more about this.
Actually, before this project, Antennas for School, we also made in competition for Czech and Slovakia kids and students.
What is this?
This is a mission patch. This is a logo of the mission who send our satellite into the orbit, and we told kids to manage to navrhnout.
To create,
yeah, or design some mission patches, the logos, and this is the final that we made from few ones. Yeah, so this is our mission patch, and it was a competition for kids. So our other project, and now our second huge project for the popularization, I think, is Antennas for School, which means that we developed antennas, small antennas, and we will distribute them into the schools, and the teachers with students can build them together and just join the radio signals from the satellite, and they will be able to communicate with our satellite through the radio.
Communicate? How do I communicate with the satellite? Please tell me.
With the radio communicating. So we can send into the satellite that, for example, take me a picture of the Earth with the camera, or just turn on the LED lights that are here on the sites.
And that can do anyone?
No, anyone, but we are able to make this
with your antenna.
Yeah, with our antenna, and children's in school can use these datas or the numbers in the physics lessons or something.
That's wonderful that you bring this to kids and to children, that they can actually see it on real data and not just in books. It makes it immediately more interesting. Tomáš, you do actually something similar. You also try to popularize science. You have your own association, which is called STEM Hub. Can you please tell us more about this?
Actually, when Ančka said about the real data, I just remembered one thing. If I only encountered physics in school, I would never do it. There wasn't anything more boring than that. So actually, that's actually why STEM Hub was born, because when I got into research, I was about 15, and it was extremely hard. Like no one will let you anywhere near a lab when you're 15, especially when you have plans like I would like to research that. I would like to research that. No one will ever let you in. But I didn't want for everyone to have it as hard, like to convince people again and again. It was like convincing tens of people. I remember that first time when I was searching how to start research, I had success rate of about like 10%. Like the rest, just the professors just didn't have an answer, and so that's why I started this association, which currently with my other non-profit organization, which also works with science students or potential scientists and researchers, now supports over 6,000 Czech students. And
how old are those students? Those are high school students? Or how we
for example, in STEM Hub, we have, and I'm very proud about that, because we have everyone like from elementary school, and our oldest members are PhD students.
Wow.
But the most of them are high school students, which is about like the target, because, and this is not an issue for whole Europe, but it's very like Central Europe specific, that even though we have very rigorous system of like educating in STEM, I think that many of you have experienced that, like biology, chemistry, physics, everything. There is a decreasing percentage of people who go into to study STEM, science, technology, engineering, etc., because it's so appalling, and I know from my own experience that, as I said, I would never study it. So this association, you mentioned STEM Hub, supports students, I hope future scientists, in discovering what it means to be a scientist, how it's done, how to start researching something when you are young, but also like finding your own path, finding if science is for you, and to actually show the students what science and innovation is.
I would definitely sign up if I was a student.
Perfect.
But tell me, guys, question for both of you. Like, you do so many things in your young age. Do you feel sometimes that it's maybe like too much pressure on you because you're young? Anna?
I think.
And I hope I'm not putting
Tomáš
pressure on you right now.
Say Tomáš can start. Okay. Yes. No, I think like all the things that I've been doing throughout the years, they are like deeply fulfilling. Why I'm doing that is that that's what I want to do. That's what I want to do with my life. That's what I enjoy. I enjoy seeing actual effects of my work, like helping people. That I build things that are actually helping people, whether it's non-profit, whether it's well-being tech, whether it's PURA, whether it's cleaning the water. But of course, even from things that you love, you can still go mad. So yeah, you need to manage your mental health. Like otherwise, no, you will go mad.
Do you have any tips for that, Anna, how to handle your mental health healthy?
Unfortunately not.
What keeps you motivated?
More time for sleep.
Yeah.
I think that the most difficult thing on our projects is the time and the talking with the people.
Like us tonight.
No. To přesvědčit.
To convince
To
them.
convince them that we are making something that can help, and when we don't have
I understand.
once
I understand.
in school, we can be smart, or we can be interested in something else, and that the school or the subject is not everything, that we can make something by the school and
But did it help maybe to win, because you both won very prestigious competitions which are internationally recognized? Did it help with people taking you more seriously?
In a sense, yes. What Anna said is very much true. When you are young and you are trying to do something, and we are very, very young. I'm 19, you're 19 as well?
20.
20. Anna is 20, and so you are not only working on innovation, you are not only working to improve the world, let's say, but you are also fighting the system in a way, because there is a very poor support for young people. So often, as you said, you often need to convince a lot of people. So did it help? Yes, of course it helped, but there is inherent prejudice towards people. Like, essentially, when I say that my age starts with 1, it's like the
It doesn't get better.
it doesn't get better. Let's say it doesn't get better. So yeah, it's still very difficult, and you often need to prove constantly to someone that your ideas were worth it, that they are, and that you are very capable, because there is often this like age limit. Oh yeah, that's what I've heard when I was 15. I studied at the Academy of Sciences, and I've heard many times, just complete your school first, go away, and then come back maybe. With your PhD or something. But we are losing talent there. Like, there are things that are not bound to age, and we need more support for people like that.
Do you agree, Anna?
Yeah, and I can say that some doors were, some door are closed now, but many more doors are open. I mean that, for example, my friendships in a class with my classmates ended because
You didn't have time for them, did you?
No, but I...
you were too smart.
No, I was many times at some excursions,
Excursions, yeah.
Excursions, or some interesting actions, and I was not in school, and I had a very big absence.
Yes, absence.
And by this absence, I had also some success, but not in the school. And then the classmates were like, "You are not in school, and when you are here, you can write the tests like us, and then you have same grades as us, and
So maybe some jealousy from them.
Yeah, and you don't have to be there. So they were. I don't know how to say it.
I think it's sometimes hard to understand very smart people. Yeah. No, but one question to you, Tomáš.
Sorry, I need to interrupt you because there is like one important thing that I think we also talked about, because there is often with young people there is this myth I try to bust that there is some like cult of a young genius, right? Because I don't feel like a genius, number one, and number two. There are many talented young people and that deserve support, and there isn't like something like they will have. I don't have 200 IQ. I started as a
only 190.
Not even, probably not that. I'm not interested. I do not want to. I do not want to know. But the thing is, I started as a very, very sick child, and no one ever believed that I will like even complete high school. I was very bad, and there is no like proof or sign that you can spot. Oh my God, this person will be talented, because it often leads to like distinguishing between people. Oh, this is like cult of a young genius. I hate that. There is nothing like that. There are just talented young people that are capable, that deserve our support.
And I think it's not just about talent, but it's also about hard work. Because if you didn't hard work, you wouldn't be here.
Science is not about talent. Science is only about hard work. Like there is nothing like having a talent for science. Yeah.
Let me touch one more thing with Anna, because you also had another big success, because you went through 6 rounds of selection for this project called Czech Journey to Space, and you actually experienced with them weightlessness in a special aircraft. So how was it? And this is actually why you have this cool spacesuit on you. So what did it surprise you the most when you were on weightlessness space?
Yeah, I'm not a Smurf, but I'm one of the 26 cadets, and we had the incredible experience with the weightlessness, because last March.
It was March 30th. I remember because it's my birthday.
Was a special plane in the Czech Republic at Prague Airport, and it makes with us parables. So the parables, 16 parables. And in every parable, you can feel the weightlessness for about 22 seconds. And it was so amazing because I don't know if you ever seen some video of astronauts on the ISS, with the weightlessness, but it's something that I couldn't
describe. Is it hard to describe?
Yeah, it's really hard to describe. It's something like that.
Is it like falling or
no?
Not really.
No, because you don't feel the gravity. The gravity is around you also when you are flying in the plane, but because you are falling and the plane falling with you.
So it doesn't feel like you're falling.
Yeah, you can feel the weightlessness. But when you're inside the plane and don't feel the air pressure, then you feel nothing. So it's really like in a dream when you dream about something and you actually don't feel your body, or I don't know, when you dive in a pool and imagine that you don't feel the water around you. So it feels like you are in some space or in a room, but you can fly and you don't feel nothing. You are like a pair of eyes just flying in a space.
Did it make you feel sick?
No.
Did you vomit?
No.
No, but you told me that the other colleagues
other
had
colleagues,
problems.
yes.
How many?
8 of 26. But I was happy to be okay.
To not vomit.
Yeah, I really enjoyed the whole flight.
I could speak to you for hours because it's very interesting, but I would like to give some space also to our people who are here with us. So please, you have some time to think about questions. If you already have some, just give me a sign and we will give you a microphone and you can ask. But in the meantime, do we have some? Yes, we have already 3.
Hello. First of all, incredible work, and genuinely kudos to the both of you for advancing both European and Czech science in particular. I hope that you have a very wonderful future ahead of you, and I would love to see the maturity of your technologies and your experiments down the line. Perhaps more of a direct question would be more towards the gentleman. So in terms of commercialization, you said that one of the main issues you saw was bureaucratic. I was curious if you had any idea if there are any other issues that you foresaw even at this early stage. Has anyone maybe approached you with potential for venture capital or any kind of funding, or is there any kind of water treatment from a public level that have been interested in maybe some kind of public procurement contracts? Yep. So basically, to come and kind of summarize it, is the issue just bureaucratic, or are there other dimensions to it which you can already foresee from now?
You are absolutely right. And one thing you are very spot on is the venture capital. No one, or I will not say no one, but most of venture capital will not go for a sector that is so heavily regulated as water treatment plants. That's something that needs to be a state initiative, because that sector is so over legislated and so usually monopolized by the state, that no venture capital will venture into that. That is one issue. There are, of course, challenges to overcome with the technology, like the scaling up. For example, currently we are focusing on how this technology could be used for fertilizers, for enriching the water with fertilizers, because that's a segment that is less heavily regulated. From what I know from the investors, the main issue is this segment is extremely heavily over-regulated. So they basically leave it up to state or European initiative.
Does that answer your question? Oh, yeah. Yeah, we can go for another question. You can ask later, maybe.
Thanks for very nice presentations. I have 2 questions for Tomáš, a joke one and a real one. There are scientific theories that lightning hitting water again and again and again helped to create life by establishing more complex chemical compounds, which were then used by first cells. So aren't you afraid that by hitting water again with lightning,
didn't happen so
far, full of bacteria and antibiotics and drug metabolites, that you will create another life, bacterial life, drug-based and unkillable? No, but the real question is, what happens with those things in the water that you are trying to purify? Yep. They don't disappear, they have to change into something else.
So I will keep hitting the water. If I create any life, I will get back to. So far, nothing. I've seen only dead life. But that's a very good question, what happens with that. Because, it doesn't magically disappear, of course. But if you think about it, antibiotics and drugs have very, very specific shapes. They are very specifically designed to target certain things. And if you break them just a bit, they will stop working, and they will be what we call, they will not be bioactive. So they will have no effect on humans. And the thing is, they are mostly made of carbon. So if you hit them hard enough a lot of times, they will eventually convert into water and CO2. And there will be some leftovers, like let's say chlorine, but those are seriously less harmful than what was there beforehand, because like having one molecule of antibiotic versus one molecule of or one atom of sulfur is a huge difference, because like one of them is much more potent.
And chlorine is there anyway, right? We clean it with that.
Yeah. So exactly. So it usually decays into something that is already there anyway.
Yes, one more question over there. Thank you very much for the floor. First of all, congratulations. You're working on great things, and I highly admire you. For us, people that do not have STEM backgrounds and are working in the European institutions, could you maybe help us understand how critical is it to solve the problems that you're addressing with your research? So, for example, for Anička, we're seeing so many satellites being deployed to space right now. We're talking about deploying AI data centers to space. So, like, how essential is it to actually develop a well-functioning system of like satellite removal and trash removal from space? And the same question would, I guess, go for Tomáš. Like, how critical is it to solve the problem of drinking subpar water? Like, what will happen if we just keep on drinking the water in its current condition? And maybe, if you actually already manage to quantify it or map the consequences, because I think that's also critical to selling the idea and commercializing it. Thank you. Anna?
So the space debris problem is, and will be. And this problem is one of the hugest, in the space industry. So we are not the only ones that are solving this problem, and it I think I know that, for example, ESA, the European Space Agency, the European NASA, solve also this problem and make also the resources or the
It's okay. We can get back to it as well. We can just I'll let Tomáš answer first.
So the problem of that's a very good question of quantifying what's the actual effect of it, and it has a lot of layers because there are lots of drugs and chemicals in the water. So I will just take one of the layers, which is like the most it hits you in the eye, which is the antibiotics. The fact that we are basically, imagine currently our water treatment plants are a little bit like incubators. We are concentrating the antibiotics, and we are basically breeding antibiotic resistant strains. There are estimates that it could kill about 40 million people to the year 2050. So, and that's the effect of only antibiotics. As I said, so far we are mostly, us as humans, like the antibiotic resistance will affect us, but us as humans, as directly like drinking this water with like antibiotics and stuff, we are still mostly spared. The issue becomes more and more relevant with time, and at the time it becomes irrelevant, it's a bit too late. But antibiotics one side, the other side, our environment, which suffers greatly already now because, as I said, we are pouring the pharmaceuticals, we are pouring the drugs, we are pouring the antibiotics down the rivers. So basically, our environment is currently suffering what we'll be suffering if we are forced to reuse our own water, which there is a lot of talk about water independence and water sustainability, especially with climate crisis going on. This is something that needs to be solved because it's not easy to just like circulate water. Like before starting this research, I imagined, okay, yeah, we are just cleaning it in the water treatment plants, just go straight to our sinks again. No, because the water is not clean enough to go back into our sinks. So that's a big issue. So it's not only people's lives, our environment, our health, because there are currently studies showing that even these tiny concentrations can affect our health. And it's also the water sustainability going to the future. So as I said, we currently still have some time, so we should work on it now.
And Anička, the European NASA that you mentioned, do you think they're doing enough?
Yeah, of course.
Yeah. So why we have so much space trash?
So we as a mankind, we are sending these satellites or another objects into the space every week. So we are also making more and more space debris to the future. And it's really I'm sorry.
It's okay.
Ineffective.
Ineffective.
It's really ineffective. Send these satellites with some motors and in the future just change their way in the space. So we are not able to solve the problem that they won't hit each other. And we have more and more space debris, and also, for example, the ESA is working on another solution, how to deorbiting the space debris. And for example, the Nancy Conrad, the founder of the competition Conrad Challenge, she was a wife of Pete Conrad, the third person on the moon. She said at the competition that she thinks that someone who can find the solution for the space debris, he or she will win the Nobel Prize. So it's a really big issue, and we must working on the solving this.
And maybe you will be the one solving it with your project, actually. So good luck with that. Do you have any more questions? Yes, the gentleman here.
Okay, thank you for a very interesting discussion. So there's one fundamental difference that I see between your project, and this is a question for Anna, Anička. Your project has the potential for weaponizing, I guess, that someone might use similar concepts not to deorbit debris, but jam or deorbit communication satellites of the enemy, etc. Did this ever, or is this an issue, or did this ever arise in your discussion, either in your team or with NASA? Or do you feel, if this is an issue, that you have some responsibility for that, or that's a general question, maybe even for Tomáš. Does a scientist have, how much responsibility does a scientist have for all of the ethical and moral implications of his research?
Very good question. Thank you for that, Anna.
It was our talk in the team, but it was because we found that when will someone, or can I say it in Czech? Kdyby chtěl někdo zneužít toho laserového paprsku, tak by to mohl udělat už dávno a zároveň by to mohl využít kdykoliv jindy. Přišli jsme na to, nebo myslíme si, že cokoliv užitečného jde použít jako zbraň, ať už se jedná o sestřelování nějakých důležitých satelitů nebo důležitých objektů nebo čehokoliv jiného. Prostě vždycky se to dá zneužít a záleží jenom na tom, kdo má ty ruce na tom, k čemu to bude sloužit. Takže za nás už je tohleto vyřešený, protože zkrátka, kdyby to někdo chtěl postavit, jako teďkon pracujeme vlastně na jednom z nejvýkonnějších laserů na světě, kterým budeme schopni zasáhnout a deorbitovat to kosmické smetí. A kdyby ho chtěl někdo vyrobit, tak si ho sám vyrobí a nebude se nikoho ptát.
Let me just quickly translate for those who don't speak English, even Czech, even though I think loads of people here do. So basically, you're saying that if anyone wanted to misuse it, they would already have done it, because you have to create a really powerful laser beam that anyone could have done if they wanted to misuse it in the past. Basically, that's what you said. Because actually, what we didn't mention before is that you really need, even for deorbiting such a small satellite, you really need a really strong laser beam. So it's not that easy to do that. So I guess for deorbiting a bigger thing, that would be almost impossible right now. Am I right?
Yeah. Thank you. And also, we were talking already with air traffic controllers and etc. And we are able to make some window for the hitting, so it couldn't hit any other object that we won't hit.
And Tomáš, your view?
Plus, there are easier ways to deorbit a satellite if you really wanted to. It's easier to destroy than to remove the debris afterwards. With the ethical question, you, like, in a way, yes, you are obviously responsible for what you research, but the other question is, as I said, science isn't about there isn't, if you invent something, there isn't only one person that can invent that thing. Scientists are very special people. There are a lot of geniuses, but they are not that special. If that, you get what I mean. So if Oppenheimer didn't invent the atomic weapons, someone else would. So that's always the consideration to make. And then it depends how you, as a researcher or as a scientist, work with it. And that's a very important thing. Scientists are not just like people kept in a separate room that you just sometimes, under the doors, there will just appear some papers that you take and implement them or build it. Scientists also need to be, or have to be put in power, in like managers. They need to do these ethics consideration as well. A lot of the issues that you are mentioning often arise from the fact that we are treating scientists just like, as I said, like people in a box that we just pull out the ideas sometimes. They are just living in their own world. No one understands them really. But no, like scientists also need to learn to communicate the science. They also need to learn to manage, etc. And this also comes with the ethics consideration they have to make.
And I know that we have a lot of other questions here that I invite you to ask our young scientist in the networking part, which will start right now. So thank you very much, guys, for coming tonight. Yes, please. Tonight, we really heard that age is not a limit in your stories. The stories proved it. Thank you very much for that. And also, I would like to thank to the organizers, Czech Liaison Office for Education and Research, together with representation of the South Moravian region to the EU. And of course, big thanks to Prague House that hosted this event. And I'm looking forward to see you again in some other event. Goodbye.